Okay, we want to make a normal curve out of that. So the center, the average is 62 with a deviation of 18. So a normal curve. Okay, so the center's at 62. Now it's saying up and down 18. So 62, if we add 18 to that, would be 72, 80. So one step up would be 80. And 62 minus 18, whatever that is 44. So that's one step up and one step down. Like a z-score, see that's 0, that's 1 up, and that's 1 down. That's what a z-score, that's how a z-score goes together with standard deviations. Okay, 2 steps up is another 18, so that would be 98. So that would be like a z-score of 2. And 44 minus 18 is 26. So it goes down to 26 at 2 below average. And then 3 up, another 18, 98, 108, 116. And 18 more down would be 8. See, that's like -3 and +3. Okay, so that's what it means. Draw a normal curve with the parameters. They don't really want, she didn't really want that. I was just doing that as a teaching tool. This is what z-scores are. So this really is not part of the answer as far as parameters. Okay, part B, shade the region that represents the portion of the plans that charge less than $44. Okay, so shade less than $44 right there. Those are the percentage of plans that are less than $44. Suppose the area under the curve left of 44 is 0.5, so basically 16%. Provide 2 interpretations of this result. Okay, so 15.87% of plans are below $44. Provide 2 interpretations of what this means. 15.87% of plans are further below 1 standard deviation from the mean. Something like that. That's a stretch. That's all I can think of. So see, 44 was 1 standard deviation below. Assume the random variable x is normally disturbed with mean 50 and deviation 7. Compute the probabilities. Be sure to draw the normal curve with the area corresponding. Okay, here we go. Center is at 50. So here's the standard deviation 7. So 1 up is 57, 1 down is 43. So 7 more up, 50 would be 64. 7 more down would be 35. Okay, so that should be enough. Now remember, 1 deviation is the middle 68%. So I already know that's 68%. That's 34% below and 34% up. Let's see. The next one is 90. So remember, it's 68, 95, 99, 7. That makes this little section in there 13.5%. See, that's 2 up and 2 down. So this is 13.5%. See, if we add all that up, 68 plus a 13.5, that's 95 total. So 95 total is between, there's 1, 2, okay, so 68% is the middle, which makes it 34 and 34. 95%, which makes it 13.5, 13.5. And then if we ever need it, that's 2.5 more up and 2.5 more down. See, that adds up to 9 to 100%. Okay, so they want above 35. See, that just happens to be right there. So that's that much, above 35. Well, the only thing it doesn't have is that bottom 2.5%. So if we add all this up, 13.5 plus 68 plus another 13.5 plus the 2.5, it's all of it except the bottom 2.5%. So 100 minus 2.5 is 97.5%. That's how much area is from 35 and above. Okay, let's draw this one. So there's 50, so they want it at 45, but one step down is 43. And then another step down was 35, going up was 57. So it's the same beginning. But see, on this one up here, they did it right on the 35, so we could actually see by those z-scores that we know. Now they want it at see, that's a z-score of 0, that's a -1, and that's a -2. They put it at 45. See, there's 40. If that's 43 and that's 50, see, the 45 is right there. See, as a z-score, that's like somewhere like -0.8. Just kind of guessing. Okay, so that's how come you find a z-score. A z-score is what you have, which they call xi, minus the average over the standard deviation. Sometimes it's written like this. What xi means the individual score minus the average over the standard deviation. Okay, so see, this is standard deviation when it's everybody. This is standard deviation for a sample. For this case, it doesn't matter. They just said standard deviation and average. So our z-score is what we're talking about, 45, minus the average, 50, divided by the standard deviation, 7. Okay, 45 minus 50 is -5/7. Okay, so if I did it on a calculator, 45 minus 50, there's the top, there's the -5, divided by 7, it's 0.71, -0.71. See, I got pretty close. It wasn't at 0.8, it was at -0.71. Okay, so we need the area under that curve. It's a normal curve, and we want the cumulation. So we need normal CDF of -infinity up to -0.71. That will give us the area from -infinity up to -71. See, we didn't need that up here because it happened to be right on a tick mark. We could have done it like that up here. See, we could have done -2 to +infinity. That would have given us the same thing. So we need a distribution, normal, CDF, a low end of -199, an upper end of -0.71. Okay, actually we didn't even have to, I forgot, we didn't even have to do the z-score because you could have put in the average was 50 and the standard deviation was 7. It could have just done it like that. 0. Whoops. Okay, I'm getting this is if you convert it to a z-score. If we do what I just did, sorry, I forgot you knew how to do this. We could say a low of -199 up to what they actually, so you don't have to turn it into a z-score. You could just leave it the raw data up to 45. when the average is 50 and the deviation is 7. See, your calculator will actually do the z-score for you. So if we do it like that, normal CDF, a low of that, now a high of 45. If I'm going to use the data, I got to put in the actual data, a score of 45, when the average was 50 and a standard deviation was 7. So my calculator makes you put it in like that, and then it types it like this. You just type it straight in. 0.2375. That's the same thing as 23.75%. So 23% of the scores are below 45. Okay, so here's the 50. One deviation down was 43. Another deviation down -7 is 35 again. Up 1 is 57. Up 1 more was 64. So that's like 1 step up, 1 step, 2 steps up, 1 down, 2 down. But now they want it between 40 and 65, so like between there. So we can normal CDF, a low of 40, a high of 65, when the average is 50 and the deviation is 7. So normal CDF of 40. Let me delete a whole bunch of this stuff. Normal CDF of 40, high of 65, average of 50, deviation of 7. 0.9074. %, 91% of the scores are between those two numbers. Okay, assuming a random variable mean 50. Same scenario. Up 7, down 7. Find the 81st percentile. So the 81st percentile means 81% below. Okay, so the 81st percentile, let's see here. Inverse norm, so if I go to distribution, inverse normal gives us the same thing down there. So how much area? 81. So you're going to type it in like this. Inverse norm 0.81 comma 50 comma 7. So I have an average of 50 with a deviation of 7. See, that's how it put mine into inverse norm. 81, what area is below 81? 50 comma 7. So that score is a 56.1. So that score right there, I didn't draw it very good. It was actually right here at 56.1. So 81% of the scores. So 81st percentile means 81% below you. Okay, normal, average, deviation. Okay, so here we go. Normal, 266 is average, so 16 more. 266 plus 16 more is 282. Okay, what proportion of the pregnancies are at 270? So see, 270 is right there. And they want to last more than 270. So we want 270 and above. So we're going to do normal CDF a low of 270, a high of infinity, average 266, deviation 16. So normal CDF gives you the percentage. Inverse normal, you put in the percentage and it gives you the score. So if we want the percentage, there we go. So normal CDF. Have a low of 270, a high of infinity, a deviation of 266 and an average of 266 and a deviation of 16. So it typed it all in there for me, just like you have. So you have to type yours in with the commas, but the percentage above that is 40.1. 40.13, which is what they have. Oh good, we got this one right too. I didn't see the answers there. What proportion lasts less than 250 days? So here's 266, so 250 is right here. So we want to go from negative infinity up to 250. So now I'm going to type it in. Negative infinity up to 250. Average 266, deviation 16. That's got an area of 1587. Okay, now we want to do between. So there's the middle, 266. They want to go from 240 up to 280. So a low of 240, a high of 280. So a low of 240, a high of 280. Average 266, spread 16. 0.7571. Okay, that's not, did I not type that in right? 240 to 280 with a middle of 266 and a spread of 16. 240 to 280, 266 with a spread of 16. Normal CDF 240 to 280, spread of 16. I actually think she might have that answer wrong. It's pretty close, but I think either I typed something in wrong and you see it, or I think that she has that answer wrong. Okay, what's the probability that random selectability lasts more than 280? So this is just pretty repetitive. There's 266. We need 280 and above. So we want normal, CDF, low of 280, high of infinity, 266 to 16. Okay, so a low of 280, a high of infinity, 266, spread 16, 1908. I think she actually typed in a couple of these incorrectly because I'm pretty sure we're doing that one right. She's off by about the same amount as she was off on the last one. What's the probability that random selected price lasts no more than 245? Okay, so we got to figure out, does that mean no more than? So think about 266. Is 266 no more than 245? So that's really asking for it's not going to go more than that. So it wants the bottom tail of 245. What's the probability that select lasts no more than 245? So this is probably going to be a small number. So we want normal CDF, a low of infinity, up to 245, with 266 as the average, spread 16. Okay, so distribution, normal CDF, a low of -1 to the 99 power, that's negative infinity, an upper of 245, 266, 16. 0947. Which again, I think she must have typed in something wrong. 9%, where we're still really close. A very premature baby is one whose gestation is less than 224. Are very premature babies unusual? Okay, 266, back up 16 is 250. Back up 16 is 234. Back up 16 is 218. See, that's average. That's -1, -2, -3. So a 224 is somewhere right in there. So see, there's barely any room there. So is it unusual? Yes, it's unusual. What's the probability? So we just need that little, so it would be normal CDF of negative infinity up to 224 with 266 as the middle, spread 16. Normal, negative infinity up to 224, 266 spread 16 is 0043, which is what she has.